slide. Hello, everyone. I'm Oliver, and I'm presenting with my colleague Pradeep on how we use Terraform at hotels.com. And in particular, how we use it in a collaborative way and have not just our operations team running Terraform code, but also get our developers to write Terraform as well. So here's me. I'm a principal data architect, so you might hear a lot of things in this talk about the data world and data infrastructure, but don't worry about that too much, because it applies to all Terraform infrastructure. And I'm somewhere cold at the moment, by the looks of it. And Pradeep, big data engineer, so also working in the data world, and he's somewhere hot. So moving on, who are hotels.com? Well, we're one of about 20 brands of the wider Expedia Group. You might have heard of some of our other brands, such as Expedia.com, Agencia, or Verbo, our vacation rentals business. But this talk is going to be primarily focused on hotels.com and our journey to the cloud using Terraform. So stepping back, 3.5 years ago, we were in the data center. And if you wanted, a development team wanted to push an application to production in that world, here are the steps they needed to go through. So they start by ordering some hardware. So they go through our procurement team. And they had to install and configure that hardware. So the networking team in the data center had to go and put the racks into the data center and plug in the networking. And an operations team had to go and install those operational applications. So some of the core services, such as health checks, monitoring and alerting, CPU collection, disk usage, etc. And then finally, the development team, so a DevOps team typically, could go and deploy their application. Now, if we look at some trends through this process, we can see that as we go down through the different phases, the time taken to do each task decreases, and it decreases significantly. So the procurement, if you're in an enterprise business like Expedia, can take a few months. So physically installing the hardware can take weeks, if not a month. But down to deploying the application. Now, we work in a DevOps world. We use continuous delivery. So we can deploy every day, every hour, or even every minute. Now, we can also see the number of people, the number of skilled people in the different areas increases as we go down these phases as well. So we have our ordering hardware team, so our procurement team, and the data center team. There's very few of them, and they work across the whole of Expedia Group. But the operations team, we have just for data within hotels.com, we have about 4 or 5 people working in that group. But our development engineers, we have maybe 100 just in hotels.com data engineering. So you can kind of see as we go down, we have more people, and we can scale better. So now let's jump into the cloud. So in the cloud, we no longer need to procure hardware, and we no longer need to physically install it. But those tasks get taken up by our operations team. So our operations team, basically, they do the procurement, and they do the physical installation. But no longer is it physical. So these days, they just use infrastructure as code, or Terraform, to do that work. Now, if we look a bit more carefully, we see that what they're doing is just scripting. So they're writing Terraform. Maybe they know a bit of Ansible, or a bit of Go as well, and they write a bit of them. But our developers, who develop the applications, well, they code as well. So they write Java and JavaScript. But they also tend to know scripting languages. So they might write some Python, or some Go, or some Bash. Now, it's not a big leap to say, well, why don't we have our development teams stepping up a level and doing some of that heavy lifting of actually the installing of the infrastructure themselves? And that's what we've aimed to do to be able to scale the business. So we've got kind of 6 themes we've been working through, and we feel are important to actually get to this level of allowing our developers to deploy their own infrastructure. Now, number 1, and always number 1, is security and auditability. Now, whatever we do, we must ensure we have a good, strong security posture. So even though we're giving our developers more power. We need to document and version control our infrastructure. So we use GitHub for that. We need configurable environments. So how do we go from lab to stage to production and ensure we have consistency as we step through those different environments. And we want code reuse. So a development team might use a piece of infrastructure, but maybe there's another development team over here, another part of the business, or maybe even another business entirely that wants to reuse that same infrastructure. We want to provide a way of allowing those kind of reuse in a modular way so that we can scale and allow our developers to collaborate together on infrastructure. And because we're now treating infrastructure much closer to just any other code, we also need to look carefully at how we do automated deployments and testing of that infrastructure. So as I said, I'm going to walk through the steps and the journey that Hotels.com have gone through over the last 3.5 years, moving to the cloud, how we've rolled out infrastructure as code and the patterns we use there, how we do code reuse, how we've been doing automated deployments, and much more recently, how we've been looking at testing our infrastructure. So let's start with infrastructure as code. So we use GitHub heavily for this. And the idea is that each application has its own GitHub repository. And traditionally, the application code and maybe the documentation was in that repository. But we want to have our infrastructure in the same repository. So in theory, you could go to a new AWS account, you could run Terraform apply on any one repository, and you would get a complete deployment of that infrastructure that would be ready to go. But in reality, it's not as simple as that. Because we need to ensure our security posture, we separate out our networking and our IAM. So things like VPCs, subnets, NACLs, Direct Connect, they're all in the networking layer, and they're owned by our operations team. And IAM, equally, user permissions, roles, and policies, they're in the IAM repository. But we actively encourage the dev teams to go and make pull requests on those different repositories. So if a team is running Redshift, for example, and developing that application, and they need a specific role or policy, they can go and make a pull request on the IAM repository. And the ops team that own that repository just need to assess that, understand the security, and if it's accepted, they can then merge and push that through to production. But we try and allow our developers as much power as we can give them. So I'm going to take a look inside one of these repositories now. So let's take a look at our data lake. So if we actually take a look at the infrastructure code within that repository, so don't worry too much about the application code. So this is how we deploy to different environments. So here we have a lab in US East and a prod also in US East. And we want to ensure that we have consistency between lab and prod. So what we do here is we have a master directory. And the master directory contains the common code that's going to be used in both of those different environments. So in this case, we have a file called apiary.tf. Now, in Hotels.com, and actually in the wider Expedia, our data lake's just called apiary. So don't worry too much about that. But this is the infrastructure to spin up our data lake. And you'll see more about that in the demo later. We also have provider.tf and variables.tf. So we try and separate out our Terraform files into clear, logical components to make it easier to understand. So then if we have a look at our lab in US East, or prod US East directories, we can see we have symlinks referencing those files. So we ensure consistency, and the same environment will get deployed in lab as prod. And yeah, it's a bit painful to set up this symlink infrastructure, but once it's set up, it just works. Now, there's also two files that are specific to those environments. So we have a backend.tf. So this is where we store our state. Now, our state is stored in we use remote state, we store it in S3 in a bucket within those environments. And we encrypt the file, and we also lock the permissions down so only the people who need to see it can see it. And we highly recommend everyone does that because there can be secrets stored in those state files. And then there's the Terraform TFRs file. So this is your configuration for the environment that's specific to those environments. Now, if we look at how we actually run this, it's really simple. So we enter one of the directories. So here, lab, US East 1. And we run Terraform init, plan, and apply. And you can see, so this is a reference to the backend file. So it's just pointing out our remote state. And you can see we encrypt the file. We encrypt the file too. So how are we doing so far? So by separating out the networking and the IAM, it gives us a level of security and auditability and some control around that. By using GitHub, we have documented version-controlled infrastructure. And using the symlink pattern, we get configurable environments. Now, with that symlink pattern, we kind of got some code reuse between those different environments. And if there's another team who wants to go and deploy their own instance of the data lake, for example, well, they can fork the code or they can copy and paste it. So it's probably better code reuse than we had in the past when stuff was spun up manually. So I've kind of marked it yellow, but we're not really there yet. And talk a bit about that next. So when we started with Terraform, we were about, like I said, 3.5 years ago, we were using Terraform 0.7, maybe version 0.8. We were in super early days, and we didn't really understand how we were using it. Since then, we've learned more, and we've discovered Terraform modules. And we use these heavily. We highly encourage these are used heavily. So if we go back to our GitHub repositories, so we have repositories for our different components, whether it be the data lake, RStudio, Redshift. And our objective is to make them into thin layers that are deployable, but just source different modules that we can build that are generic, that can get reused. So coming back to our data lake as an example. So our data lake sources a module called data lake. So we've basically taken all of that core infrastructure code and we've moved it into a module. And actually this module can be found on public GitHub, and you can go and find it and use it yourself. But not only are other public people looking at this repository and looking at this module, across Expedia, other teams also use this module. So Hotels.com has a data lake, which is deployed using this infrastructure. But also Expedia.com has a data lake using the same module, as do Verbo, as do Agencia, as do lots of other parts of Expedia, which is great. But if you're in the data world and you're talking to your analysts, having lots of siloed data lakes is quite frustrating, because the Hotels.com analysts want to compare Expedia data or Verbo data or Agencia data. So we developed a module called Data Lake Federation, which basically makes lots of data lakes look like one data lake. So it allows us to have silos and independent units, but also join those data lakes together. And our main data lake repository, our deployable artifact, now sources that data lake federation module as well. So the other module it sources is our tag module. So within Expedia, we have a set of governance and standards around how we must tag our infrastructure. So we created a module for it. And the data lake repo sources that as well, as do all of other repos. So they all source the tag module. So let's look at another example. Oh, one sec. So we have modules for lots of other things as well. So like Qbol, SES, IAM. And all of the main GitHub repositories have just become thin layers that are sourcing these different modules. Now let's just take a look at another example, just to show a slightly different point. So Qbol sources the Qbol module and the tag module. But the Qbol module also sources the Bastion module and the NLB module. So having a hierarchy of modules where modules source modules is a perfectly accepted and in fact encouraged practice. So how do we use these modules? So it's really simple. So to use a module, we source the module like this. And you can see the repository there. It's on public GitHub. You can go away and look at it. And there's an example of a couple of parameters you pass into that module. Later on, Pradeep will show the full set, and there's a lot more parameters than this in the demo. So our modules, they're on public GitHub, some of them, and you can go and find them there. Or they're on an internal repository. But our ones on an internal repository are made public to all internal users. And we strongly encourage users to reuse, raise issues, and create pull requests on those modules. So this is about our collaboration. So we have over 75 modules in Hotels.com, and there's over 30 contributors. Now, remember earlier I said we have about 4 or 5 operations people, maybe 100 developers within the our data part of the organization. So we've got about 1/3 of our developers actually developing Terraform modules, which is great, and that's exactly what the kind of culture we want to encourage. So now we think we've done a pretty good job with code reuse. So now I'm going to hand over to Pradeep, who's going to talk about automated deployments.
Thanks, Oliver. Hi, all. So I'll start talking about the automated deployments. As we move into the production, we don't want to basically deploy any stuff manually because it's error-prone and it's kind of boring. So we want to have some kind of a pipeline which can take the code from the GitHub or any version control, take the changes, and just deploy into the environment which we want. So we use Jenkins for our pipeline, and we developed a Jenkins in a master-slave architecture, where slaves has capabilities to deploy stuff on our AWS. It has a proper permissions. It can, and then once the jobs are run, it can send email communication or a Slack notifications to the operations team or to the respective team. It just takes the Terraform code from the version control, runs a plan, sends a plan, and if a person is happy, just approve it, and then it runs an apply and sends again a notifications. There are some application code which could require some confidential information or a password, something like that. For that, Jenkins can get those details from a Vault or AWS Secret Manager and pass it to the jobs so that those are not hard-coded or passed via a version control system. Here are some screenshots of our Jenkins, which deploys our API data lakes. So we are deploying 4 different environments like Analytics, Lab, Prod, and Sandbox. So this is just a screenshot of deploying in our Lab US East 1 region. So with using Jenkins for our Terraform code, we have checked the automated deployment box. We have a confidence that, okay, the teams, different teams can deploy their Terraform code using Jenkins, and it's kind of automated process. Now, but with this automated process, we don't have a test yet, and you don't have the confidence that whatever the code developers are building is actually test like a well-written. It's not going to do any harm to the existing system, or it works as expected. So we want to cover some testing features. So how we are doing a testing? We don't have really extensive testing for a Terraform at the moment. We do a basic testing like a static code analysis using Terraform validate, which just checks like the Terraform syntax, it's right or wrong. And we have developed some Python scripts, custom script, which scans the code and just check like whatever the government's rules we have, it adheres to that or not. Those are not really extensive, and we continuously encourages our users to build more and more tests for the code base. And then post-deployment, we use AWS spec, which is an RSpec-based library to check the AWS infrastructure, and plus some custom RSpec tests, which are not available out of the box using AWS spec. Here's a long wish list which we have for the testing, which we have categorized in a 4 different ways: offline development, functional testing, integrated testing, and the production testing. So in the offline development, we want a developer who is writing a Terraform code can do some level of a testing on his own workstation using static code analysis, which we have pretty much, Terraform validate. But the thing we don't have is a unit test. So we would like to have some like a mocking framework which could do some testing at the workstation. We have searched a lot on the internet and haven't come across any good tool. So yeah, we are continuously working on developing something, or if you guys have come across anything, please share with us as well. Then for the functional testing, we deploy in the lab QA environment, see how the Terraform code is behaving, run some post-deployment AWS spec test, and see the system is working as expected. In the integration testing, we deploy the incremental change in the pre-production environment and just assess that the system behavior is still consistent and it's not behaving in a weird manner. And then in the production testing, we want that once we deploy the code in the production, it works well, and we don't want anyone to make changes outside Terraform. For example, if I'm creating a security group using a Terraform, I don't want anyone using AWS CLI or AWS UI to make changes to the like that security group rules or something like that, because everything we want to manage by a Terraform code. So we are not green yet. That's why we are amber. We don't have a full testing, and we are continuously working on improving our testing strategy for the Terraform code. So with all these principles, let's put it together and see like how we deploy our Expedia data lake, which we called as Apiary. And before we look into the Terraform code, I'll just give a quick introduction what our data lake looks like. So the data lake uses the different AWS services like S3 Bucket, ECS Fargate Cluster, RDS, Private Link, CloudWatch, AWS Secret Manager, and other stuff. So a data lake has different types of resources, and it's really hard for a data ops team to deploy this data lake in a different environment without Terraform. Like if you go with a script, it's really hard to deploy these data lakes in a consistent manner. So we developed a Terraform module which can deploy this whole data lakes in a few minutes and in a consistent way, and we can deploy this in multiple environments. And at the moment, I think we have more than 10 different deployments in the production using these modules. So the code becomes really simple. So if you see, like we just source the Terraform modules called API Data Lake, and this is available on our GitHub, Expedia Group GitHub. Pass some basic AWS parameters, some data lake related parameters, container size, and so on. And then it gives you the whole data lake which we saw in the previous architecture diagram. So I have a demo. So let's see like how it works out. So here I'm just setting our AWS credentials, and first I'll just run our AWS resource command to see if there is any resource with the tag apiary.dl demo. So I've just run that, and there's nothing, so which means like this is a clean environment where apiary is not deployed. Now I'm just initializing my, from the application code, I'm initializing the Terraform repository, which downloads all the dependencies, including my public GitHub modules and different AWS resources, the providers like null, template, AWS, and whatever is required for the code base. So it's successfully initialized and set the backend. Now I'm going to run a plan on that. Yeah. So the plan, and I'm going to save in a data lake.plan file just so that I can reuse that file and do auto apply on that. So once I run a plan, it basically queries a lot of data sources to get different things from the AWS API and scan all the code and just show me like what it is going to do. And so if you see, it's going to basically add 54 different resources, which is really hard to deploy when you're doing, let's say, with a bash script or writing your own code using AWS SDKs. So now I'm just going to take the plan and apply it. It will take some time. I've edited the video so that we don't wait. It will just quickly finish. And if you see, it's deploying the security group, creating RDS cluster, creating load balancers, and different AWS components which is required for a data lake. So it's creating and running some local script to set MySQL stuff. So here we see like its apply is completed. All the 54 resources are up there now. So now I'm going to run the same AWS command to see like if I see any AWS resources using AWS CLI just to validate. So yeah, I see a bunch of resources. I see security group, RDS cluster, S3 bucket, load balancer, and so on. So it's so easy. The whole process maybe just take less than half an hour. It's just that like RDS instance takes time. It takes the majority of time. So within few minutes, you get a whole brand new data lake, and few different teams can just deploy using a module consistently. So we have been using Terraform from a long time, and there are some tips and hints which we have learned so far. Want to share with you guys. So what we have learned is to use a separate Terraform state file for each application and environment. In the past, we tried like merging 2 applications or 3 applications in one state file, but that doesn't work out well, because if there is a problem in one application, it could basically cascade the effect on another application or something like that. So reduce the blast radius or contain the problem. Just suggest like have a state file for each application in an environment. And then logically separate the Terraform code. Instead of writing the whole code in a, let's say, main.tf, like 10,000 line, we like just suggest every developer to write a different TF files within a folder so that those are logically separated. For example, if you have an application which is going to create few IAM roles, S3 buckets, something, so have IAM.tf put the IAM-related content there. S3.tf, put S3 bucket-related code there, so that it basically looks clean for any third user who wants to read your code as well, and it just looks cleaner. Modules. We have learned modules are really good in the Terraform. It allows us a very good code reuse, and it just makes a code really easy and clean. And we suggest every developer to version them so that if you are doing incremental changes in the module, you don't break any application code which is using some version of your module. Well, sometimes you might introduce some breaking changes, and other teams are not ready to accept those breaking changes based on their sprint planning and etc. One repository per module is better, because then you can version them each. You can version each module separately, and it just allows you to scale the module development really nice. We can use AWS Secret Manager or Vault to store sensitive information, encrypt the Terraform state file, and make sure that the state files are properly, like S3 bucket policies are properly set, so that the only set of user can access your state file, so that they can't make any changes like accidentally. And version the S3 bucket where you're storing the state file, so that you have the backup in some accident case someone deleted. And we also replicate those S3 bucket to different region, just for disaster recovery. And we use data source heavily instead of Terraform remote state, because we don't want to depend on someone else's remote state for API, AWS API, which we can get from the Terraform data source. So to summarize, we encourage within the hotels.com and different parts of Expedia to use Terraform in a collaborative way. Use modules, do code review, use Jenkins or different types of CI/CD pipeline, and do some testing. But all these things come and needs a change of culture, which is really important in the company. That's it. Thanks for your time. Thanks for listening to us.